Problem sheet 3, question 6. A blood diagnostic centre can be described as an MM1Q. Blood samples arrive at a rate lambda per time unit. Once in the centre, whether being processed or waiting, the samples need to be kept cold at a rate of CH per time unit. An automated diagnostic machine can process the blood samples one at a time at a rate of mu per time unit, which can be controlled. It costs mu CS per time unit to run the machine at a rate mu. What should the machine's service rate be set to in order to minimise the overall cost? So if you want to minimise the overall cost, first of all we need to write an expression for the overall cost. So let's call the overall cost C. There are two components to the cost of keeping everything cold. So it would cost CH per time unit, and on average we would have L samples per time unit, L being the average number of blood samples in the system at any time. The second component would be the cost of running the machine, which would be mu CS per time unit. So this is the overall cost per time unit. We have an expression for L, because this is an MM1Q. We know that L is equal to rho over 1 minus rho. We can now see that C is a function of mu, and rho itself is a function of mu. So if we substitute in rho for lambda over mu, we would get, and we can simplify this to get and this is now a function of mu. So now we would like to minimize this function. So remember, we can find the minimum of a function by setting its derivative equal to 0. So what would dc d mu be? We can set that to be equal to 0, and we can do some rearranging to get which mu satisfies this equation. So we get two roots of this equation. So we get mu is equal to plus or minus root CH lambda over CS plus mu. So which root do we take? Well, the clue lies in this line here. From stability, we know that lambda over mu must be less than 0. And so lambda must be less than mu. If lambda is less than mu, then mu minus lambda must be positive. So we need to take the positive root here, and so we know which root we care about here. So it looks like we've answered the question. However, setting dc d mu equal to 0 gives us a stationary point, so that could be a maximum or a minimum. So we can check that this is a minimum as we require. And we can do that by taking the second derivative test. And substituting in our value for mu. And we can look at this and go, well, 2 is a positive number. Lambda, the arrival rate, will be positive. Our costs will be positive. This square root will be positive, and to the power of minus 3 doesn't change the sign. Therefore, this will be positive. And so the value of mu that we found is indeed a minimum. And so our answer is that mu is equal to root CH lambda over CS plus lambda.